Hey, it's Professor Dave. Let's check out the night sky.
He knows a lot about the science stuff. Professor Dave explains.
It's taken almost 10 billion years, but we've finally made it. We started with the Big Bang. We watched atoms form. We saw these collect to form stars and galaxies. We saw those stars explode to disperse the materials that would become all the planets, and we watched our own solar system form, including the planet Earth. Thus begins a new chapter of the story. Upon this Earth, biomolecules arose, polymerized, and became contained in cell membranes. Life was born, which slowly evolved and eventually brought about human beings like you and me. This fascinating chapter of the story is told by the fields of general chemistry, organic chemistry, biochemistry, and biology. Check out my tutorials on those subjects if you want to know more about that whole show, since it's more than a little involved, as one might imagine. But otherwise, to get back to astronomy, once human beings were thinking and talking and forming civilizations, they started to look up at the sky and wonder together about all the things we've been talking about so far: stars, planets, and the penetratingly deep dark cosmos. What did they think about all this? How did they begin to figure out all of these things? Let's take a moment now to see what they saw and try to make sense of their thoughts. Early civilizations saw a night sky that was virtually the same as the one we see today, or at least the one we can see from a rural location, far away from all the smog and light pollution found in a large city. Objects have shifted their positions slightly, but apart from that, our ancestors saw thousands of stars that seemed to be fixed on some celestial dome or sphere, slowly rotating around us. They kept track of their positions by inventing constellations, or shapes that can be traced by connecting the dots. They require quite a bit of imagination to see, but our ancestors were creative and probably quite bored, so they projected a little bit of themselves onto the stars. They also saw other objects, most notably the sun and the moon, as well as 5 planets, all of which moved according to their own patterns, unrelated to the stars. The planets were named for gods, and their Roman names are the ones we still use today. For a long time, we believed that the Earth was the center of the universe, with the mysterious heavens swirling around us. While this notion seems utterly ancient to us now, it was the only conclusion we could have made in absence of any scientific knowledge. The planets moved along a particular line through the sky, but a bit more slowly than the stars, and the constellations they crossed in doing so were viewed as special. These were the constellations that came to comprise the zodiac, which are still the focus of astrology today, a relic of mysticism from times past. But some of what we learned in those times remains valuable today. We began to understand the cycles in the sky, and we used them to understand time, the seasons, and other phenomena. The most obvious unit of time that mankind has understood since prehistory is the day. The sun rises and the sun sets. This is the most noticeable cycle to any Earth dweller. But other cycles were visible too. The moon goes through phases in a predictable way, and this became the basis for the month. Over longer periods of time, we noticed seasons, or regular periods of warmer and colder weather. This became the basis for the year. These are all units of time that mean nothing whatsoever elsewhere in the universe, but on the Earth they mean everything. They punctuate our human experience. Now let's discuss some more subtle observations we made over many generations. First, the stars rise and set just like the sun and the moon, and they do so resembling one huge sphere, with their distances from one another fixed. But after looking long enough, we realized that there is one point that doesn't move at all. In the northern hemisphere, this is called the North Celestial Pole, and the southern hemisphere has its South Celestial Pole. These coincide with the north and south pole of the Earth, and the reason for this is fairly intuitive in a modern context. The star directly above the axis of rotation for the Earth will appear not to move, because the North Pole is a point that experiences no lateral motion as the Earth rotates. This star, the North Star, was useful for navigation for thousands of years and remains useful to this day, leading any navigator in a northward direction, no matter where you're standing in the Northern Hemisphere. But for reasons that we now know have to do with Earth's motion around the Sun, the celestial sphere changes very slowly throughout the year. Different stars are visible at different times of the year, as well as different constellations, and this was an important method of marking the passage of time. Rather than any meaningful message from the gods, this phenomenon occurs simply because we can't see stars behind the Sun, because it's way too bright, and at different times in Earth's orbit around the Sun is blocking different stars. We can only see stars during nighttime, when the half of the Earth we are on is pointed away from the Sun. So some constellations go missing and others appear until we get back to where we started, all in a predictable annual cycle. The line that the Sun traces in its movement across the sky is called the ecliptic, named as such because if the Moon crosses this line, we have the potential to see an eclipse. We now understand that this line, followed by the planets as well, is simply the plane of the solar system. But the Sun's path changes depending on the time of year, in a way that correlates with the seasons. So what are seasons, and why do we have them? Many people think that this has to do with the Earth's distance from the Sun. Farther away, colder, winter. Closer, hotter, summer. But summer in the Northern Hemisphere happens at the same time as winter in the South, and vice versa, so that can't be right at all. Instead, the seasons occur because of the tilt in Earth's rotational axis. This is the imaginary line that the Earth spins around. As it turns out, this axis is not perpendicular to the plane of the solar system. It's actually 23.5 degrees from the vertical. This means that one hemisphere is getting more direct sunlight than the other at certain times of the year. In the summer, the axis of rotation is tilted towards the Sun, and the Northern Hemisphere gets the most direct sunlight, while the Southern Hemisphere gets sunlight at an oblique angle. So the Northern Hemisphere gets more heat and more daytime. In the winter, the axis of rotation is tilted away from the Sun, and the Southern Hemisphere gets lots more sunlight. More heat and more daytime, while nights get longer and colder up north. This tilt also explains the varying angle of the ecliptic. Because of the way the Earth is tilted during different times in orbit, the Sun will rise and set at different places in the horizon. The spring equinox, or vernal equinox, as well as the fall, or autumnal equinox, are the 2 days where the Sun crosses the celestial equator. The summer solstice and winter solstice are the days where the Sun is the furthest away from the celestial equator, rising and setting furthest north or south. These days mark the passage of the 4 seasons, and we were able to observe this in the sky long before we knew why it happened. Ancient monuments like Stonehenge in England are very clearly structures based around these phenomena, as in this case, the openings between stone pillars are meant to frame the sunrise and sunset for an observer standing at the center, specifically on these special days. Other monuments, like pyramids and temples, exhibit some kind of alignment with the Sun on certain special days as well. But contrary to whimsical conjecture, it is not necessary to evoke aliens or magic to explain this. It is just the result of careful observations of the celestial sphere over many generations. Lastly, the ancients were fascinated by the Moon, as it is the only object that significantly changes its appearance over time. The Moon has cycles in which it waxes and wanes, from full to new to full again, with crescent shapes in between. These are called the lunar phases. Their explanation is quite straightforward, and contrary to popular belief, it has nothing to do with shadows. Only the face of the moon that is pointed towards the sun is illuminated, and therefore visible. If that side is pointed towards Earth, when the moon is opposite the sun, the moon is full. If pointed away, when the moon is on the same side as the sun, it's new. Anywhere in between, and we get a crescent of some kind. If the moon passes directly between the sun and the Earth, that is called a solar eclipse, and the moon will completely block out the sun, leaving the Earth in its shadow. When the Earth is directly between the sun and the moon, leaving the moon in Earth's shadow, that is called a lunar eclipse. These were mysterious sights in the ancient skies, often interpreted as ominous signals from the gods. But just as with everything else, we began to learn how to predict these events as well. Let's continue and see what happened next in our quest to understand the cosmos. Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.